Okay, we're going to use hypothetical thousands tables. A thousand tables is where we break everything down into parts of thousands. Like we're saying we have 1,000 people and we create this table to help us answer our questions. So here we go. Got Kathy and Doug, cars in need of desperate repair. On any given day, the probability that Doug's car will break down is zero point 0.5. So out of 1,000, Doug, oh yeah, got to define. D is Doug's car breaks down. K is Kathy's car breaks down. So here we go. So D, Doug's car breaking down is 500. That means 500 times it doesn't break down out of 1,000. Kathy's is 600 times out of 1,000 it breaks down. 400 it does not. And then it says the probability that both their cars will break down is zero point 0.3 or 300 times out of 1,000. And then to find the rest of it, we subtract, let's see, 300 times plus what gives me 500, that's 200. 200 plus what gives me 400 is 200, and this is also 300. Okay, so 3 plus 3 makes 6, 2 plus 2 makes 4. So the question asks, what's the probability that Doug or means to add, Doug or Kathy's car will break down? Okay, well, where are the places where they do break down? Well, here's both of them, as well as here and here. So these three are all then breaking down. 3 plus 3 plus 2 is 8. So this is zero point 0.8 or 800 out of 1,000, which is zero point 0.8. Okay, now we also could have figured out, all right, the complement, they don't break down 20% of the time. So 200 out of 1,000. So 200 times they don't, that means 800 they must. So either way, we can still come up with zero point 0.8. All right, so here we go. In this case, we have the probability the football player weighs more than 230 pounds. More than 230 pounds is 6.69 or 690, again out of 1,000. That he is at least 75 inches tall. This is at least or greater than or equal to 75 inches is 550. And that he weighs more than 250 and is at least is 0.43. So that's this number here where both occur, greater than 230, at least 75 inches or taller. That's 0.43, also known as 430. Okay, then we fill in the rest of the blanks. And so the question asks, find the probability that he is at least 75 inches tall if, okay, so this is a probability, this is a conditional statement. He has to weigh more than 230 pounds. So that's this column. He has to weigh more than 230 pounds. And so how many of those are greater than? It's 43 over 69. And I'm simply going to leave that as my answer. Okay, that's 43 over 69. You can change it to a decimal if you want to. Doesn't matter to me. I'm leaving it as 43 over 69 because that's where this occurs. All right, my next question says, the probability that a home in a certain city has an attached garage or swimming pool is 0.89. Okay, so garage, whoops, not a garage, total. Pool, not a pool, total. It's out of 1,000. Okay, this number is not going to appear on here anywhere, so let's work backwards from it. The probability of the garage is 720, so that's 280 makes 1,000. Probability to have a swimming pool is 38% or 380, 620 makes 1,000. Now, we didn't have any of these numbers. None of these are 0.89, but I know that 0.89 is these three numbers, just like I did up here, these three numbers added together. So this number then is where neither occurs. So that's 11% of the time, or 0.11, also known as 110. And then I do my adding and subtracting and I find the rest of the numbers. Now the question is, what is the probability that a randomly selected home in the city has an attached garage and a swimming pool? Attached garage, swimming pool is 0.21 or 210 over 1,000. This is just easier to write. Okay, then our last one here on the front side of the page, of voters in a recent election, 57% were male. So we have male, not male, 570, 430. Male, not male, 570, 430. 64% were Democrat. Democrat, not a Democrat. Democrat, 640, not a Democrat, 360. And 35% were both male and Democrat. That's right here. That's where that occurs. So 350 out of 1,000, 0.35. So we add that plus that to get this. This plus this equals this. These work together, so everything equals 1,000. So this asks, what is the probability that a voter chosen at random is either male or Democrat? so male or Democrat. So we can do 1 minus 0.14, or we can add, because or means to add, we can add 290, or excuse me, 0.29 plus 0.35 plus 0.22. Either way, we still come up with 0.86. Okay, 0.86. I hope that makes sense to you. All right. In the words of Bob Seger, let's turn the page. Okay, here on this one. All right, we have M is that it rains on Monday, TH it rains on Thursday. So I have M and M prime total, Thursday prime, rain on Thursday, doesn't rain on Thursday total. The probability of a rain on Monday is 0.3 or 300 out of 1,000. So 70% of the time it doesn't rain on Monday. Thursday is 0.4. Thursday, 400, 40% of the time it rains, 60% of the time it doesn't rain on Thursday. Assuming these are independent. Okay, I'm going to stop right there. Screeching halt. These are independent. Then to find the probability that it rains on Monday and Thursday, we multiply 0.4. And this is where I've really had, people having problems. 0.4 times 0.3. Those are my two numbers there. That's 0.12, not 1.2. 1.2 is greater than 100%. So it's 0.12. So plus 180 gives me 300. Plus 280 gives me 400. The number here in the middle is 420. So what's the probability it rains on both days? Probability it rains on both days is 0.12. What's the probability it does not rain on Monday? Does not rain on Monday, 0.7. Look at all these things we can answer without doing any thinking. If it rains on Monday, but not on Thursday, okay, it rains on Monday, but not on Thursday, it's 0.18. It rains on at least one of these days. At least means the opposite of it rains on neither of them. That's 0.42. So this is 1 minus 0.42. This is going to be 0.58 because it's 1 minus this number. 1 minus 0.42 is 0.58. Or we could have added 0.12 plus 0.18 plus 0.28, and we get 0.58. All right, it doesn't rain on either day. It doesn't rain on Monday, doesn't rain on Thursday. There's that 0.42 again. Okay, so far so good, I'm hoping. Okay, so here we have these two events. We have event A and not A, B and not B. Probability of A is 0.5, so that's 500, 500, 1,000. B is 600 that does occur, 400 that doesn't occur, 60%, 40% equals 1,000. And the probability of A or B is 0.85. Well, that's these three numbers added together, but we don't know those to begin with. But if the probability of these three equals 0.85, then this number must be 1 minus 0.85, which is 0.15, which is 150 here in the center. Then we add to get 350, subtract to get 250, 250, however you want to look at it. There's our numbers. So here we go. What's the probability of A and B? Well, it's right there. It's 0.25, A and B. Okay, now the probability of A given B. A given B. So we're talking about this row. So we're talking about 250 over 600, also known as 25 over 60, also known as, divide both by 5, and we get 5/12. I like that answer. Okay, if you want to see what that looks like as a decimal, it's approximately 42%. Okay, so that's about 0.42. If you put equals 42, I need to go back and mark that wrong, don't I? And then here, what's the probability of B given A occurs? So that's 250 out of 50, also known as 0.5. I'm not even going to write that decimal. It says probability of B given A. Okay, B given A. So it's 250 over 500. Okie doke. So here we go. Now, here's the one a lot of people had trouble with. Red Cross says about 40% people have A, 11% have B. So A, not A, B, not B. 40% have it, 60% don't. 11% have it, 89% don't. Now, right there, there's a zero. Why in the world is there a zero there? Well, because you cannot have type A nor type B at the same time. All right, you cannot have them both at the same time. So that number is zero. So that gives us 400 there, 110 there, And that makes this number 490. That's important to us because that's what the question asks. What's the probability that this donor does not have type A or type B? So we want A prime and B prime. A prime, B prime, it's 0.49. 49% of the time, 49% of the population don't have either one of those two blood types. I figured it'd be higher than that, but who am I? Okay, and here we are on the last one. So M is married, G is a college grad. So you're either married or not married, graduate, not a graduate. And so it says probability is college graduate is 58%, so 580 and 420, it's 1,000. The randomly selected worker is not married, that's M prime, that's 350, that makes this 650. Then it says back up at the beginning, employment records indicate that the probability a worker is married if, so it's a conditional probability, he or she is a college graduate is 55%. So if we're looking at the college graduates, the 580, we're trying to determine what percent of them, or how many of them, are also married. So that's 580 times 0.55. 55% of the 580 people who are college graduates are married. That's 319. That's the reason why there's a 319 right there. That makes this 261, makes this 331, makes that 89. Okay, then it asks, what is the probability that the worker is neither married nor a college graduate? So here we go again. Married prime, graduate prime, this prime. None of those occur. That is 0.089 or 8.9%. Sorry, 8.9%. I hope that's clear to you. Hope you have a good rest of the day.